are going to study about the exponential functions, and we will see that how the functions shows the variation when there is a growth in the function and there is a decay in the function. We will also practice some of the real life equations showing that how the exponential growth functions can be shown mathematically by interpreting the word problems. Are exponential functions. Remember that if we have a function, let's suppose f of x or y equals to a b to the power of x. A is a coefficient, b is said to be the base, and x is the exponent. So what is the main basic thing is that in the power, if you have a variable as a function, then it is said to be an exponential function. So far, we have studied, like for example, x to the power of 4. So what have we seen? That in this function, x is the base. X is not in the power, x is a base. So this is not the exponential function. But if I write the same function, but I write 4 to the power of x, now 4 is the base, whereas the x is the exponent, means the variable is in the exponent, then this function is said to be the exponential function. So the most important thing is that the power must have a variable x. So you will see there are two kinds of the exponential function, either the exponential growth function or the exponential decay function. When we talk about the growth, of course, any function which is increasing, whenever, if something is increasing, then it is said to be the exponential growth function. Wherever the exponential function, if it is decreasing, then it is said to be the exponential decay function. Let's check that how can we write the exponential function and how we can determine whether it is showing the exponential growth or decay. So as I said, that the general formula of exponential function is a b to the power of x. Now a is the initial amount, yani how the function is starting or how any kind of the situation is starting. So that is the initial amount and that is said to be the a. Now this b is the base of the function. So for example, the population of the bacteria is doubling. So what is the base? The base is that the population of the bacteria is doubled. So the base is b. So on the power we have to write the x. Now everything depends upon the base. So if the base is greater than 1, which means it could be 2, it could be 3, it could be 1.5, 4, 5, 6, whatever the base, but it is greater than 1, then we can say that it is the exponential growth. So something is increasing. But if the b is between the 0 and 1, okay, it should not be only less than 1, but it should be between 0 and 1. So for example, it is 0.25 or 1 over 3, because if you convert 1 over 3, it will gives you 0.33, or half, because when you convert it is 0.5. So if our base is between 0 and 1, then it is said to be the decay function, or what is happening? Exponential decay. So b greater than 1, exponential growth. B is between 0 and 1, shows the exponential decay. So here we already have studied a b to the power of x, whereas x is the exponent, b is the base. If b is greater than 1, we have an exponential growth, whereas b is between 0 and 1, we would have a exponential decay. How does the graph of exponential growth and exponential decay is shown? We always read the graph from left to right, means how we write the English language, okay, words, same way we have to read the graph. So look at this one. What is happening? If you are standing here, so you can say that the graph is increasing, okay, it is continuously increasing. So even if you are running over here, you are going up and up and up and up. And where you will stop, you don't know where you will stop, so you are keep going up. So all x values, all real numbers are your domain, but the graph is also increasing. That's why it is said to be the exponential growth. But what is happening here? If you look here and analyze the graph, what is happening? The graph is decreasing, continuously decreasing, decreasing, decreasing. Now, here it seems that as if it is touching the zero horizontal line, whereas it won't touch the zero horizontal line. It will keep going, and the distance between the zero will be minimized, but it won't touch the zero line. This is said to be the exponential decay. So this graph is representing exponential decay. So what have we learned so far? That graph increasing, it is exponential growth. The graph decreasing, so this is said to be the exponential decay. And the other thing, if mathematically we say that the value of the b is greater than 1, shows the exponential growth, whereas the b between 0 and 1 shows the exponential decay. Have a look over here. So keep it in mind that the main formula is a b to the power of x. So in the first example, what have you seen? 4 is your a value, 2 to the power of x. So 2 is the b. And what is the value of the b? It is 2, which means it is greater than 1. So what do we have? We have the exponential growth. Now here 0.25. Now before 0.25 there is no number, which means there is 1. So what is your a value? The a value over here is 1, whereas the b value is 0.25, which is less than 1 and greater than 0. So here it shows the exponential decay. Here 5 to the power of x plus 1. Actually, I am not going in the depth, but if you look closely, it can be written as 5 to the power of x and 5 to the power of 1. Now 5 to the power of 1 actually gives you 5, and then it gives you 5 to the power of x. So this 5 is your a, and 5 to the power of x, this 5 is your b. Only focus on this b. The b is greater than 1, which means it is the exponential growth. Now look at the next question. F of x equals to half power of x. Now before the half there is no number, which means 1 is hidden. So our a value is a and our b value is half, and b is between 0 and 1. That's why it is exponential decay. Now for each value of the form a to the power of bx, you have to identify what is a, what is b, and you have to determine if it shows the exponential decay or the growth. So the most important thing is that before the bracket, this is the value of a, that is 2, and the b has the power of x, the value is 6. So if the b is greater than 1, so it is what? It is our growth factor. Okay, and what is the reason? Because they are asking you to give the reason to support your answer. So reason is that b is greater than 1. Here the a value 3, 7 to the power of x. So 3 is our initial value, whereas the b is the base, which is 7. And b is greater than 1. So it means this shows the exponential growth. Next function is y equals to 2 times 1 over 3 to the power of x. So the initial value over here is this 2, whereas the b is 1 over 3. And if you write it in the decimal, if you write in the calculator or divide yourself, 1 divided by 3, it will give you 0.33333, which is less than 1 and greater than 0. So it shows the exponential decay. Now next question. 5 times 3/4 whole to the power of x. Now if again you will change the, so here it is decay. So if you will see here, a is 5, whereas b is 3/4. If you write in the decimal, even if it is less than 1 and greater than 0, so you will get a decay function. Next question, 5 times 2 to the power of x. So here the initial value is 5, whereas the b is 2, and it shows what? Growth, definitely. Why? Because the b is greater than 1. This is our reason. Now number 6, do it yourself and write your answer in the comment box. The table and graph the exponential function. So first of all, find it out that whether it is what is the a value and what is the y value. If you look at the function closely, so here before the 6 there is no number, which means it is the hidden 1. So a equals to 1. And what is the b value? The b value is the base, which is 6. Now if we look here, the 6, it is greater than 1, which means that it is the exponential growth function. Exponential growth function, if I just visualize, it looks like this. It looks like this because I know from my experience, and we just studied about this, that the exponential growth functions looks like this. Now they are asking us, what is the domain? Now, have you seen, if you look, just analyze this graph, do you see any discontinuity in the graph? No, the graph starts from any number and then it goes on and on and on. And if I put any number, for example, if I put any negative number, let's suppose negative 100, yani 6 to the power of negative 100, if I put in the calculator or I try to calculate, it will gives me 1 over 6 to the power of 100. It means there is an answer. If I put here 6 to the power of 0, I have an answer. If I put here a positive number 6 to the power of 2, it will gives me 36. It has a number. If I put 6 to the power of billion, for example, okay, so does it gives me the number? Yes, it gives me a number, which means any number I put, I get an answer. So what is my domain? It's all real numbers. Okay, nowhere it becomes the undefined. It means all real number. So either write like that, all real number, or show in the interval notation as negative infinity till positive infinity. Now what is range? I have studied just now that what happened to the exponential function, that it starts from it doesn't touch the 0. A little bit it will come closer to the 0, but it doesn't touch the 0, and it goes on and on and on and on. So it means that the range is from the 0 till the infinity for all exponential growth function. Since 0 is not included, so I write a small bracket, and for infinity I always use the small bracket. Now what is a y-intercept? Y-intercept actually means that when x is 0, what would be the value of y? So if you put here, it is our function is y equals 6 to the power of x. In place of x, if I write the 0 and I write in the calculator, or even the mental math tells me that anything having a power 0, answer is 1. So my answer is y-intercept is 1. Y equals to 1. But also remember that whatever the function is, y-intercept actually is the value of a. So look at this, we just find it out before that the value of a in this function is 1. That's why the y-intercept is 1. So what is y-intercept? It is actually the value of a. Now they are asking us to graph. Now what you do, you take the two negative numbers and take two positive numbers. Always start from negative 2, negative 1, 0, 1 and 2, and that's it. What we have to do, replace the x by the first number, means y equals to 6 to the power of negative 1. Write in the calculator, you will get approximately 0.02. Now write y equals to 6 to the power of negative 2. Write y equals to 6 to the power of negative 1. You will get a kind of 0.166, I guess. Now write here y equals to 6 to the power of 0 because we are keep replacing the x value. It will give us 1. Then write y equals to 6 to the power of 1. Answer is 6. Y equals to 6 to the power of 2. The answer is 36. So what we have seen that as the number of the x are increasing, the y values are increasing. Now just a little bit quickly, make it 0 and 1. So it is here. Here is the 0 and the y value is 1. Now 1 and 6. So this is the 1 value, and if I go up, this is the 6. So this is my point. Then 2 is 36. So 2, and if I go on the 2 and somewhere on the top over here. So how does I know that the graph is a kind of a very smooth curve? A very smooth curve. Okay, you have to make it solid, but because I am making here. And after that even you write 0.02 or 0.01, it comes very close to the 0, but it won't touch. So what you have to do, you just make a graph, okay, a smooth curve by connecting all the points. And I cannot make it very nicely, but you connect them with a smooth curve because I am using this pen which doesn't let me do it on the graph. That is it. So make a graph and extend it, but don't touch the x-axis. So is it the exponential growth or decay? So it is the exponential growth because the b factor is greater than 1. Let's make one more graph, 2 to 3 to the power of 6. So what is our a? The a value is 2, whereas the b value is 3. Now 3 is greater than 1, so I am writing over here is growth. What is the domain? It's all real number, which means negative infinity till positive infinity. Range for every exponential growth function, the answer is 0 till infinity. Y-intercept is actually the a value, and the a value in our case is 2. Now what we have to do? We will choose the x values, that is negative 1, negative 2, negative 1, 0, 1 and 2. And we will write one by one in the calculator to get our answer. So replace all the x by the values which you are choosing. You can choose other values also, but these are the very reasonable values, and it doesn't go out of the graph as the function is increasing. So you have to choose very fairly the values. Okay, now write it in the calculator one by one and get the answer. So 9 times 2 is 18, 3 times 2 is 6, and this is our 0, and it will gives us 2 over 3, and this will gives us 2 over 9, and whatever the values are in the decimals. Okay, now try to make it 0, 1 and 2. So on the 0, the answer is 2. When it is 1, the answer is 6. So here. And on the 2, the answer is 18. Now I just make the 3 values. I don't like to take more values. I join them. Don't go on my curve. Anyway, extend them. Extend the values. And over here, extend, don't touch the 0, but come closer to the 0 value. So this is how the graph of the growth function looks like. Make one more graph so that you can practice. So the domain, as we said, what is the A? A is the 5 and B is the 3. It's a growth function because the 3 is greater than 1. Now, y-intercept is actually the A value, which means the 5. Domain is all real number, which means negative infinity till positive infinity, and range we memorize 0 till infinity for any growth function. So here it is our growth. Now we have to graph it. So we take the values -2, -1, 0, 1 and 2. So wherever the x is, you have to replace one by one with the values, that is -1, then -2, then write 5, 3 to the power of -1, then write 5, 3 to the power of 0, then write 5, 3 to the power of 1, and in the end write 5, 3 to the power of 2. So 5, 3 to the power of 0, it gives us 5. This will give us 5 over 9. This will give us 5 over 3. And here 5 times 3 is 15 and 3 is a 9. 5 nines are 45. So these are the values, but only try to graph only 0, 1 and 2. This is my suggestion. On the 0, the answer is 5. On the 1, the answer is 15. And on the 2, answer is 45. Yani very far. And just make the join them by making a smooth curve. Don't go on my curve, please. And after that, come closer and closer and closer like this, okay? But try to make it very smooth curve, not like me, because I cannot make the curve very nicely here. That's why it looks like this. You don't make like that, okay? Next question. Here is another function which you have to graph. Now, if you look closely the graph, what you will see that the A value is 3, whereas the B is 1 by 4, which is 0.25, which means that it is the decay function. It shows the decay. Now, domain for all the exponential functions is all real number, which means negative infinity till positive infinity, means whatever the value of the x you will substitute, you will get an answer. Now, the range is also from 0 till infinity, same as the growth function. Y-intercept, I told you that it is like the exponential growth function. Y-intercept is y equals to a, which is 3. Means when x is equal to 0, the y value is 3. Okay, now let's find out that how can we create the table. So the same like before, that take the 5 values -2, -1, 0, 1 and 2. Substitute the x value. So 3, 1 over 4 to the power of -2. Y equals to 3. Then substitute 1 over 4 to the power of -1. Y equals to 3, 1 over 4 to the power of 0. Y equals to 3, 1 over 4 to the power of 1. And y equals to 3, 1 over 4 to the power of 2. Now, if you write one by one in the calculator, the first one will give you the 48. When you substitute by -1, you will get the 12. When you substitute by the 0, you will get 3. And then so on, right? The most important thing is take the 3 values at least. Okay, so on the -2, you get the 48, which is very, very above. Okay. On the -1, you will get 12. Then on the 0, you will get 3. And coming closer and closer and closer to the 0, but it won't touch the x-axis. Okay, and you can just extend it. So again a smooth curve, and you can see that the function is decreasing. That's why it is a decay. Let's try one more last question to understand about the graph. Again, practice the graph by saying what is the A. The A value is the first value, initial value, that is 5. B is the base of the x, which is half, that is 0.5. Now, what is domain? Domain of any exponential function is all real numbers, and range of any exponential function is from 0 till infinity. What is the y-intercept? So when you put the x value as a 0, y-intercept will gives you the a value, which means in this case it is 5. Since the b is greater than 0 but less than 1 half, so that's why it is showing you a decay. After that, we have to choose at least 5 or 3 or 4 values, -2, -1, 0, 1 and 2. And now put one by one in the calculator in place of the x to get the y values. Now when you are doing in the exam, please show the work clearly so that there are no chances of marks deduction. So the value is -2. So when we put the value in place of x, we put -2, we get the 20. And when we substitute -1, when we substitute the -1, we get the 10. When we substitute the 0, we get the 5. When we substitute 1, we get 2.5. And when we substitute the positive 2, we get 1.25. So you can see that as the x values are increasing, the y values are decreasing. So on the -2, it's 20. On the -1, it's 10. On the 0, it's 5. So let me just say, on the 1, it's 2.5, and on the 2 is 1.25. So you can see there is a smooth curve and coming closer to the 0, but it won't touch the x-axis. So make a very smooth curve and extend your curve till the end to show that how the graph is decreasing. So this is how we create the graphs. See you in the next video to explain you another idea.